Okay, look up. They're asking you to do an integral. So you should be thinking to yourself, okay, this isn't f prime, but temporarily I will think of that as being f prime. Therefore, I need to find f. So I need the antiderivative. So I remember my flashcard right here. There's certainly not a rule. Next thing I try is U-substitution. I want to show you a trick I've not shown you before. It's super close to what I've already taught you, but it's a little bit quicker. So back here, and for this problem, we're not going to worry about the limits because I just don't want that complication right now. So we're going to do one together in class, but we're going to do it as though it's just an antiderivative. So don't worry about it for homework. Please skip number 1. We'll just do it together. Okay, I'm going to try U-substitution because the rule doesn't fit. It's number 1 on the out. I'm going to try U-substitution because the rule doesn't fit. First step is the same. I must see the problem as two functions being multiplied. So, cosine of x divided by 1, 1 divided by sine of x. Okay, here's the shortcut. Here's the shortcut. Just look at the two multiplying functions and pick something from one of the two. I'm going to do a bunch of wrong examples first. I look at this function, I pick x. And I think, well, maybe u equals x. But as soon as I think that, I stop because I know that never helps. So I'm never going to pick u to equal x. We need more talk there. So I try something else. I look at the first function, I pick cosine of x. Well, I think to myself, okay, what is the derivative of the cosine? The cosine is the negative sine. That's not going to work. I pick u from here. The derivative of my pick must be the entire other multiplying function. But this isn't negative sine, this is 1 over sine. So that will not work. This is my shortcut. Wait if you need to see that again. Cool. So I've exhausted my picks here. So I go over here. Here's another wrong pick. I choose all of it. Okay, I do not know what the derivative of 1 over sine x is. But I know it's not cosine. It's some mess because I have to use the quotient rule. So that's a bad pick. Can't pick x, that never works. There's only one choice remaining. We'll change color for emphasis here. The derivative of sine is cosine. So that works perfectly. I picked this from this function. The derivative of my pick is the entire other function. That's what you're trying to get when you do a U-substitution. So, question? You want to talk more about it, just wave at me. Okay, once you make the appropriate pick for u, the steps are always the same in every single problem. So once you've made the right pick, the rest goes pretty fast. You take the derivative. Remember, this dx has to match this dx. Multiply the dx across. And now you just pay close attention to the equal sign. So this is u. So I'm going to have 1 over u. Then I have cosine of x multiplied by dx. Right here, cosine of x multiplied by dx is the same thing as du. You want to talk more about that. We can do it with the limits. B-Day's not going to because we just got to save some time somewhere, but we can do it. You good to hear? Okay, so Josh asked to integrate in the limits. I need to change the limits at this point, so I need some space over here. So I write u equals, let's see, so because u is equal to the sine of, no, sorry, cosine of x. No, that was the wrong choice. Sorry, sine of x. So u is equal to sine of x. So plug in the upper limit, which is pi over 2. I remember the circle. Pi over 2 is right here. Okay, sine is the up or the down. So this is 1. Questions? Next one, I do u sine of z pi over 4. Okay, I've memorized the sine and cosine of any angle involving a fourth is always root 2 over 2. I look at the circle, pi over 4 is right here. So that's an up, not a down. So positive. So now I know my limits. 1 and root 2 over 2. You want to talk more about that.
I understand how you got 1 and root 2 over 2, but I don't get how it changed from how you had.
Hold on. So see if this helps. If it doesn't help, talk more. When we have if all we have is an antiderivative, like this, and we're doing a U-substitution, our goal is to change the antiderivative into something using u instead. Like in this case, u would equal 4 minus x squared. Negative 2x You okay with that? So when I come up here, this becomes my x times dx will be negative 1/2 du. Like that. So we've changed from an antiderivative that uses x to an antiderivative that uses u. We find the antiderivative. Like that. Then we change back to the x. So we put the x, we put this back in. You okay with that? Feel comfortable? That's antiderivative. With an integral, when we're doing a U-substitution, we have, like we had an x here, we had an x here, we had an x there. And with the antiderivative, we change all of that to u. And then we change back. With the integral, these are values of x. They don't say x, but they are values of x. So So what I'm doing here is I'm changing them to be values of u. Is that good, okay? Don't leave me yet. So far, okay?
Yeah.
So I'm hoping that that feels exactly like this problem so far. Because we're just changing everything from u to x. Good? Okay. Now what we do, all eyes on me, everybody look up. Everybody. Once you get to this point with an integral, this is where you've got to keep the ideas separate. Antiderivative, integral, very related, but enough different that you've got to keep them separate in your mind. When you do a U-substitution with an integral, it's as if you are creating a brand new problem, and you can now do the following. You can pick up your eraser and figuratively erase everything you've done. Oops, I got to do something first. Dang. Good thing I have the magic board. I need to copy this. Come on, board. There we go. Grab your eraser, erase all of this. You don't need any of it now. None of it. When you're doing an integral, you don't need any of that anymore, because you have created a brand new problem that will have that's much simpler, but it has exactly the same answer. If you pick up a calculator and you type this in your calculator, you'll get some numeric result, some decimal. If you type this in your calculator, exact same decimal. So with the U-substitution, you want to go to u and just forget that you ever even had x if it's an integral. When it's an antiderivative, they make you go back to x because all the answers are written with x. But here, all the answers are just numbers, so we don't have to go back. I don't know if I've helped at all, though. So far, okay, though. Like, it feels okay.
Yeah.
Good. Okay, so you're good for now, then. No worries. Other question? Please.
I know how to manipulate the natural log after it's, like, after you find out what it is. Like, how does the natural log of square root of 2 over 2 go into what answer? How does that?
So what Abby's done is she got to here, and then she said, look, it's a brand new problem. I can forget x completely. I'm just going to solve this. So again, she thinks of this as being f prime. And I have to find the antiderivative. This one fits a rule. So the rule says this antiderivative is natural log and then we've got to plug in these two values, so that's what the bar means. The Wilson there. Okay. So you plug them in. Natural log of 1 is 0. Absolute value of a positive number is just that number. Questions to there? I'm getting to Abby's question in a second. None of the answers look like that. Here's what they did, and I will have to confess to Abby that the first time I worked this problem many years ago, I got to here, I looked at their answers, and I'm like, I don't know. Really, like, what the heck did they do? It took me, I don't know, half hour to sit there and think about it and go, oh, I see it. So if you can't see how to get from here to here, I don't think you should stress. This problem was given in 1969 when people were really, really excited about things that were like this because there were no calculators. They have since not worried about it quite so much. So I'll show you, but you shouldn't stress about it.
Well, also number 5 and number 6, both have to do with natural log manipulation.
Those manipulate much easier. Watch. So what they did here is this. You do have to learn to do some stuff with logs, though. pretty much always put something like that on the test. I showed you that before. That's not new.
Do you just multiply together?
Yeah, root 2 times root 2 is just 2. So these divide to make 1. Here's the one most people don't remember. Natural log of A divided by B. So you've seen this before. If you've forgotten, well, welcome to the human race. We're supposed to have seen that in a previous class. Okay. Not kidding. But you don't use it very often. So if you've forgotten, I don't think you should don't feel bad. It's normal. You don't use it, so you forget it. So now what happens is I can rewrite this as negative parenthesis natural log of 1 subtract natural log of root 2. Natural log of 1 is 0. Ah, come on. Am I speaking the teenage language appropriately? Oh, fat Jew. Oh, P-H-A-T. You gotta tell me it's your language, I don't know. How do you spell it?
Oh, yeah.
I don't know. It's like living in a foreign country. I don't know what the guy is saying. Abby, that is your question.
Yeah.
That's your question. Got it. We else have anything you want to talk about here besides the lingo? Please, Lynn.
This isn't like you, because that was in 1965. Other than you problems like that one, like all of that.
So more recently, now eyes up, come on. It's a really good question. More recently, I have seen problems where you did have to remember this. So kind of keep reminding you once in a while just in case. It's not like every year, Elena, that they throw something like this, but I have seen it happen. I don't think I've ever seen this much, where like you had to remember this first, then this. Yeah, I don't remember that much, but. And it is true that in 1969 they did not use calculators at all. Like a handheld calculator, they could simply add, subtract, multiply, and divide would have cost about $1,000. I don't. That's what that's most likely. Like I know the general idea, but I don't. I've never used it. I've seen them. Yeah, by the time I came along, calculators were down to about. Like when it got to a class where you would need a calculator, they had come down in price to where it was more like about $40 for a basic scientific calculator. We didn't have graphing yet. When I started college, there were no graphing calculators. So. Okay, next one.